So in this problem we're given that the position time function is x of t equals t squared over t plus t cubed. You can interpret that handwriting. And we're asked in part A to find the velocity function. And we know that velocity is the same thing as saying x prime of t. So x of t, we've established, is t squared over t plus t cubed, which if we simplify by dividing both the top and the bottom by would be t over 1 plus t squared. That's 1 plus t squared. So then x prime of t, we're looking to find the prime of this. And so that we have to use a quotient rule, which is first, second. We want to find the derivative of the first, which is, since it's just t, is going to be 1. 1 times the second, 1 plus t squared, minus the first t times the derivative of the second, which, since 1 is a quotient, is going to be 0 and 2t, over the second squared. And if we simplify this, it's going to be x prime of t equals 1 plus t squared. That's not nice looking. T squared minus 2t squared over 1 plus t squared squared. And we can further simplify that by saying x prime of t equals 1 minus t squared over 1 plus t squared squared. So velocity equals 1 minus t squared over 1 plus t squared squared. And then this is our velocity. We have to remember that one because we're going to need to use it in other parts, such as right now, for example. We want to graph our velocity function to find when the particle is moving to the right, which is what part B asks. We know that velocity equals B equals 1 minus t squared over 1 plus t squared squared. And if we graph that, it's going to look something like that. Is not right. It's not straight at all. It's going to look something like this. Yeah, I'm not very good at drawing, obviously. So this point is gonna be at 1, and so we know that this is x equals 1, and it moves to the right whenever x is positive, whenever the y value is positive for the velocity time graph, and it's above the x-axis. So whenever velocity is positive, then it's moving to the right, and it's positive from 0 seconds. So what is it asking me? It's the particle is positive particle moves to the right from 0 seconds to 1 second. Because you can see 0 is positive, and we're ignoring this side because we can't have negative. 0 is positive right here, and it crosses over the x-axis at 1, so it's from 0 to 1 second. Now part C is asking Part C asks to find the total distance traveled between 1 second and 6 seconds. For this, we'd go back to the position time graph, which is, I'll write it again. It's t x of t equals t squared over t plus t plus t cubed. It's ugly writing, but I don't mind. Sorry. And for this one, we would put it into our calculators, because you can see that it's never going to be going, it's always going to be going backwards from 1 to 6 seconds, because you can see that it crosses over the axis right here at 1, and it never goes back over it, so it's always going to be going backwards, so it's the same as a displacement function. So we would put in our calculators this function, then we would go vars, or the absolute value. That is not how you do absolute value. Absolute value of y1 6 minus y1 1 equals 0.338 SEC. And I forgot up here the velocity to write meters per second, which you need. So then we know that it is going to be the total distance. That's wrong. It's supposed to be meters. So the distance traveled is 0.338 m. Circle this. And finally, it asks us when it's speeding up and when it's slowing down. And we would use the graph of the velocity function. And we know that it's slowing down, when it's speeding up. It's speeding up whenever either velocity is positive and increasing, or velocity is negative and decreasing. So if we look at this, then back over here, this is supposed to be like going up, but I didn't do that well. Yeah. It looks nicer if you actually put it into your calculator instead of relying on my graph. But if you look at where it passes the x-axis at 1, so it's speeding up from 1 second to, where's my graph? I want to find the minimum on the graph, and I need to zoom out.
Are you talking to yourself?
I'm recording for math.
Oh.
It's okay. From 1 second to 1.732 s.
I'll be back in 2 minutes.
See. I believe that's right, yeah. Just gonna double check that in my maxes and mins, and then I'm done. Minimum. So. Yep, that's right. And then circle this. And that's how you do this problem. Just to go over, the velocity is going to be 1 minus t squared over 1 plus t squared meters per second. It's moving to the right from 0 second to 1 second. Distance traveled is 0.338 meters. And it speeds up from 1 second to 1.732 seconds. And that's it.